right, we are going to go ahead and finish off our discussion of section 12.2. In addition to histograms and polygons, frequency histograms and frequency polygons, we may decide that we want to present our statistical information in a different way. We're going to talk about two different other potential ways. We're going to talk about stem and leaf displays and circle graphs. There are definitely other ways of presenting statistical information. So as we're going through and as we're thinking about these, we're only kind of scratching the surface as far as how we can display statistical information. Again, what we just discussed, our frequency histograms are probably the most commonly used, but these are a couple of other different ways that we may use to portray statistical information. Right. So the first thing that we are going to look at here is we are going to look at a stem and leaf display. Okay. The stem and leaf display is a tool that organizes and groups the data while allowing us to see the actual values that make up the data. So here we're actually going to be able to see each of our different individual values. We're going to record the data values using the digit or digits to the left of the rightmost digit. That's going to be the part that we're going to refer to as the stem. And then the rightmost digit is going to be the leaf. Right? So thinking about our stem and leaf plots. In this particular example, we only have two-digit numbers. So the tens digit is going to be our stem, and then the ones digit is going to be the leaf. If we were looking at three-digit numbers, then we would have our hundreds and tens digit as the stem, and then just the ones digit as the leaf. So the last digit on the right is going to be the leaf, and then we could have more than one digit to create our stem. So what we're going to do here is we're going to list each of our different data values in this table using our tens digits and our ones digit. So looking at our first data value is 29. So that has a stem as 2, and that's our tens digit, and it has a ones value of 9. So we're going to go ahead and put a 9 over there. Right, our next value is 31. So the 3, we're going to work in this row. And our ones digit is a 1. 39 would also go in this row. 43, 56, 60, 62, 59, 58, 32, 47, 27, 50, 28, 71, 72, 44, 45, 44, and 68. Right. So what we see here is by using our stems on the left, we naturally group these guys into groups based off of their ones value. Right. So we can kind of see the distribution of the data. We can see which class has the, or which stem, kind of similar to our class from our previous discussion, has the largest frequency, and we can make some different comparisons using our stem and leaf displays. So the advantages, they do show individual data values. So looking at the last one, I just left our values in the order that they appeared. We could rearrange these, so we could put each of our different leaf values in numerical order if we wanted to, and oftentimes that is done, especially if you're doing some sort of significant statistical presentation. Right. And this also helps us investigate the shape of our distribution without technology. So this is a pretty simple, quick way of sorting through our data values that doesn't require a graphing calculator or some sort of fancy technological exercise to do. Our histograms and polygons that we just talked about, we can definitely generate those using programs such as Excel and other things. Same thing is going to be true with our circle graphs, which we're going to talk about in our next example. But our stem and leaf displays are, again, pretty quick, easy displays that don't require the use of technology. The disadvantages, they are not as common as histograms that we looked at in our previous examples. And if we had a really large data set, it would be challenging if we had a lot of those data values. If we had 200 values over here, we'd have a very, very large table over here. Right? So it would be kind of a time-consuming exercise to work through and to create a stem and leaf display if we have a very large data set. Right, so the last type of statistical graph that we're going to look at in this section is we are going to look at a circle graph. Right, a circle graph is sometimes referred to as a pie chart, because our graph is going to be a circle. It's split into wedges that are kind of like our pieces of pie. Right? So they're often used to compare parts of one or more components to the whole. It shows one piece of the pie for each observed category. The size of the piece is proportional to the frequency of that category. And since the circle represents 100% of the data, the sum of our sectors should always be 100%. Cross that extra phrase in there. Okay. So in this last example, 800 people who attended a Ringling Brothers and Barnum and Bailey circus were asked to indicate their favorite performance. The circle graph shows the percentage of respondents that answered tigers, elephants, acrobats, jugglers, and other. Determine the number of respondents for each category. So we're actually going to kind of come full circle to where we started at the beginning of the semester. At the beginning of the semester, one of the very first things that we started talking about were percents. Right? So thinking about this particular example, we're going to use these different percentages, right, from this circle graph to generate our number of people that fall into each category to find those frequencies. Right? So thinking about our circle graph always needs to add up to 100%. Right? So if we were to add up all of these percents, we do indeed get 100%. Right? When we want to write percents as a decimal, remember we shift our decimal point 2 places. Right? So 38% turns into 0.38, 26% turns into 0.26, 17% 0.17, 14% 0.14, 5% 0.05. If we were to add these all up as decimals, right, well then we get 1.00, right, which is 1 whole or 100%. Now, to find our number of people, again, going back to where we started at the beginning of the semester in Chapter 10, remember our basic percent formula, percent times whole equals part. Right? So if we take our percent for the percentage of people that have favorites that are tigers, we're going to take 38% times our whole. We were told that 800 people attended, so we're going to multiply this by 800. Right? Plug it into a calculator. 38% times 800 gives us 304. 0.26 times 800 equals 208. 0.17 times 800 gives us 136. 0.14 times 800 gives us 112. 0.05 times 800 gives us 40. And just as our percentages added up to 100%, just as our decimals added up to 1, this should add up to our total number. And if we add 304, 208, 136, 112, and 40, we do get a total of 800. So our circle graphs gives us another way to present statistical data, gives us a different way to represent frequencies. Again, you will have a few homework questions that relate to your stem and leaf displays and your circle graphs. However, for the most part, our focus, a lot of times when we're dealing with statistics, one of our preferred methods is definitely the histograms, which we started with in the beginning of this section.